Here comes my second video to this recent foundation math examination, and I'm going to talk about the section B. So let's have a look. Right, there are 60 marks worth of question parts, so let's have a look at the question 1. Artificial intelligence equipment installed in large warehouses can be very hot. Water is used as coolant. So in one warehouse, the heat generated from the AI equipment in responding to 50 AI queries requires 500 milliliters of water. The average volume, so I would say 500 divided by 50, that is 10 mils of water for each query. Next one, the AI equipment in another warehouse uses between 1.8 liters and 12 liters of water per kilowatt hour of heat energy produced. Calculate the volume range in liters needed to cool AI equipment that produces 100 kilowatt hour of heat energy. Write your answers in the boxes below. So I would say the smallest is 1.8 liters multiplied by 100 let's say kilowatt hour of heat per liter. Yep, so that'll be 180. That's 180. And also the largest volume of water is 12, so 12 multiplied by 100, that's 1200 liter. Okay, so that's the answers. It is reported that Australia uses around 13,449 gigaliters of water per year. Globally, AI equipment is predicted to require 6.6 billion cubic meters of water for cooling in 2027. Conversion is 1 billion cubic meters equals to 1,000 gigaliters. Express the 2027 globally predicted water requirement for AI equipment as a percentage of the annual use of water in Australia. Give your answer to the nearest whole percentage. So basically, you have various ways to tackle this question, but what I will do is, first, this is the amount of water in cubic meters required, and I would say 6.6 multiplied by 1,000, because 1 billion corresponds to 1,000 gigaliters, so 6.6 multiplied by 1,000, which will give you 6,600 gigaliters of water. The next thing is, once you see this total amount required, this is my base number, so the percentage of annual use will be 6,600 divided by 13449. And once you get this number as a decimal, you multiply by a further 100%. So you'll be able to get, let's say, 49.0742, etc. I'm not writing the remaining digits, but then this will be approximated to 49% because the question wants nearest whole percentage as the final answer. Next question. A machinist is making pistons for an engine. A diagram of piston is shown below. The specifications require the diameter of the piston cylinder to be 87.000 millimeters with a tolerance of plus or minus 0.005 millimeters. So you have 5 pistons. They measured to have these diameters. And we would like the mean number or average of these 5 pistons. So I would say add them up and divide by 5. Make sure you have the correct number of decimal places and zeros when you enter these numbers into your scientific calculator and divide by 5. So you'll be able to get, let's say, 87.199 millimeters. From the 5 piston diameters listed above, write down all the diameters that are within the specified tolerance. So we know the desired measurement is 87.000 plus or minus 0.005. So the lower bound equals to 87.000 minus 0.005. So this will give you, let's say, 86.995. And the upper bound, or the maximum, will be 87.000 plus this tolerance, so you get 87.005. And let's have a look at these five numbers. So 87.003 is less than that, but greater than that. So this one is fine. And 88, this is even larger than my upper bound, so I don't want this one. 86.998, yep, slightly larger than the lower, but within the upper, so that's good. 87.004, yep, that's smaller than upper. And this one is even less than the lower bound, therefore I don't take that one. Eventually I write down all the diameters, so therefore we have 87.003 and 86.998, comma, and 87.004. So only these three will be the final answer, I suppose. The piston fits inside a cylindrical space as shown below. The conversion between cubic millimeters and cubic centimeters is 1,000 mm cubed equals to 1 centimeter cubed. Using the measurement shown above, which is, I believe, here, calculate the volume of the internal cylindrical space. The internal cylindrical space, well, first, it's just this bit, okay, and this bit, the internal space. So I would say the height is just here, so 60 take away 3. So height is 60 take away 3, which is 57 millimeters. The next thing is the outer diameter is 93.01. Each side, we need to have the side width of 3 millimeters. Therefore, the inner diameter equals to 93.01 take away 3. And I believe that will give you, let's say, I probably need to use my calculator. And actually, if I do that, I can do 93.01 take away 6. So I'll get, let's say, 67.01. And the radius is going to be 67.01 divided by 2. And that will be 43.505. The next thing is the volume equals to pi r squared times h. So I'll have a pi times 43.505 squared multiplied by, let's say, 57. However, if we calculate the volume in this way, our unit of measurement will all be millimeters. So eventually I want to calculate the final answer as a cubic centimeters. Therefore, I'm going to do a division at the end, okay? So that'll be, let's say, 338924.5861. But remember, this is millimeter cubed. Therefore, in centimeter cubed, the volume equals to 338924.5861 divided by 1,000. So eventually you will get, let's say, 338.9245861. So it's just like moving the decimal places 3 times to the left. And finally, the question needs you to round the answer to 3 significant figures. Therefore, you write it like 338.9, and this one should be round up, 339. Okay, so that's the final answer. Alternatively, without converting, you can actually do the conversions first. Say this is 5.7 centimeters, this is 6.701 centimeters, and this one will be, let's say, 4.3505 centimeters. Then you just chuck in the numbers in terms of centimeters. So you get a 339 at the end. In my opinion, question 3 was quite challenging in terms of the amount of comprehension, because the graph below shows the start date of the rainy season on Australia's mainland over 24 financial years. Financial years is like going from the 1st July to the next, let's say 30th of June, etc. The start dates are measured in days before or after 19th December. And if you look at the way they construct this number, this horizontal line is like the 19th of December up to plus 20 or more, let's say minus 30 something. So it's like 20 days ahead or minus 30 days before, something along this line. Now, using the graph above, consider the first monsoon season that started after 19th December. Identify the financial year in which it occurred. The first season. Find the start date of the monsoon season. Record your answers in the boxes below. So, let's have a look. We need that after 19th December, which is the first time it has let's say a spike above. Therefore, it's this column here. So I'm going to identify financial year 2002 to 2003, okay? So this is the first time. And a start date. Now, have a closer look at this diagram here. So this is like 2, 4, 6, 8, 10, 12, 14, and then 16. So basically you count, let's say 16 days ahead. So let's say 19, 20, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, okay? And then the first, second, and third, fourth, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's December, that's January. So you do quite a bit, let's say, counting, careful, okay, careful counting. Therefore, oh, by the way, you need to calculate the 19th as a day, okay? So I would say the 4th of January. Maybe you want to say 2003, but if you look at the published assessment guide, it only requires you to specify the day and the month rather than the year as well. But anyway, so that's the first part. And then state the number of times the start date for the monsoon season in Australia was more than 10 days from 19th December. More than 10 days from 19th December. Well, to be honest, we probably would think of, okay, it's 10 days later than 19th, more than 10 days later than 19th December, but also away from the 0 here, you could also see, okay, here it's more than 10 days earlier, more than 10 days earlier. So you do have to, let's say, count more than 10 days forward or more than 10 days backwards, something along this line. Therefore, we count this one, count this one, count this one. This one is lower than 10, so don't worry about that, don't worry about that, don't worry about that. Count this one, and yep, this is more than 10 days before. Yep, know these two. And this is exactly on the day of 19th December, so don't count that. Yep, this is the one, and let's say 21st November, yep. Take this one, don't take this one, don't take this one, don't take this one. This is exactly 10 days. It's not more than 10 days, so I don't count this one. This is okay. This is less than 10 days before. Less than, don't count them. Tick. So let's have a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 times, I would say. I just mark something down here. More than 10 days before or after. Okay, using this graph, interpret the data for the 2011-2012 monsoon season. Let's have a look at this one. I would say it's exactly on this date, okay? So, the monsoon season started on exactly the 19th December in 2011, okay? Yep. And write down the number of times the difference between two consecutive start dates of a monsoon season was more than 1 year. Well, I believe this one is the most challenging part. And from my own perspective, it takes quite a while to really comprehend what the question is really looking for. The problem is we would like two consecutive start dates of a monsoon season more than 1 year, which is like larger than 365 days. So probably I would, now I don't have to rub out everything, but let me just give you a quick indication. For example, suppose you start from the, this date. I don't know which date it is. I haven't calculated it yet. But if the second column, hypothetically, if the second column or second cylinder here levels with the first one, that means it's exactly 365 days in between. Suppose we don't count the, let's say, the lunar year or whatsoever. But if, let's say, the one is like with a lower edge here, then from here to here, that's less than 365 days. But if you have, let's say, a column slightly higher, then it's more than 365 days. So this is how we compare the relative position of the bottom edge and the top edge. It's basically, if the next top edge or bottom edge is higher than the previous one, I would say, okay, for these two consecutive years, it's more than 365. So that's once. And then this is even higher. Okay, very good. So that's another one. 1, 2. And then from the third year to the fourth year, you can see the edge is lower. So the difference between these 2 days will be less than 365 days. So we don't count that. But when you see another transition, can you see this is higher, which means it's later than the previous start date. Therefore, we count another one. By repeating this process, you can see, okay, you count another one, and you count another one, but then there is a drop, so you don't count this drop. From here to here, yep, you can count that one. Here to here, you can count that one. Here to here, higher, yep, you can count that one. Count again. So you tally this up. And this is another rise. Yep, we can count that one. Another drop, no, we don't count that. From here to here, yep, that's it. A drop, we don't count that. It's a drop again from here to here, no good. A rise here, so we count it again. A rise here, we count it again. A rise here, we count it again. A drop, we don't count that. A rise, yep, we count that. Drop, we don't count that. Another rise, yep, we count that. So eventually, when you tally this up, there will be 16 times. 16 times, okay? The key is count how many times it rises, okay? Well, hopefully my explanation makes sense. This is how I would interpret the question, and I use some interpretation of the graphics. Anyway, let's move on and have a look at another question. Oh, an invoice. So location and preparation for this tax invoice. 1 unit, $300. So that's just 300.00. Correct in the nearest cent. 5 times 180, that is 900. One item of 750, that is 750.00. And a 3 times 120, so that's 360.00. And a 1 times 190, 190. Eventually, when you add them up, let's say 1200, add that. 1950, add, let's say 550, that's 2500. So eventually the amount issued, the total is 2500.00, and then the GST is like 10%, so that's 250.00, and eventually they add up to 2750. I believe this is an easy to moderate invoice question. Yep, complete the invoice by filling in all blank boxes in the amount column. Good. So that's it. Two venues, A and B, are being considered for the celebration. The costs for each venue are shown as follows. Venue A is $135 per person, all inclusive. So let's do the cost A is $135 per person times the number of people. And venue B is like $75 times the number of people plus a fixed cost of 3200. And a minimum number of guests required to guarantee venue B is the cheaper option. So this one is less, this one is more. Therefore, we should have 135 times N. And this is cheaper. Therefore, I would say it's larger than 75 times N plus 3200. Then you subtract 75N both sides, you will get, let's say, 60N greater than 3,200. And you get a 30N greater than 1,600. So N is like 1,600 divided by 30. N is greater than that. And that gives you 160 divided by 3. Okay, but we need to take a whole number for that. Therefore, this will be 53.333 recurring, okay? The minimum number of guests, we can't take 53 because 53 doesn't satisfy, let's say, N greater than 53 and a 1/3. So the smallest, the beginning number, will actually be 54, okay? Of course, you could treat this one, instead of solving a linear inequality, you can just put an equal sign here and get a 53.3 recurring. Then you try, okay, when it's 53, I'm going to show you. You could do it in this way. Let me just recall from my previous calculation. So 135 multiplied by, for example, 53, it's this much, $7,155. And then 75 times 53 plus 3,200. Bear with me. I'm pretty sure it's an extra zero here. So you can see it's pretty much a 7,175. So this one is actually cheaper, and this one is more expensive. Therefore, if you try, let's say 54, 7,290, and 75 times 54 plus 3,200. Yeah, that's actually a smaller amount than the first one. So the first time, the second option, option B, is cheaper, is when N equals to 54. Anyway, that's my solution to question 4. Let's move on. Okay, a farmer is preparing an area of land to plant a crop of wheat. To prepare the land for planting, the farmer will spray the land with the fertilizer to help increase the soil's nutrients. The conversion between square meters and hectares is 10,000 square meters equal to 1 hectare. The land being used to plant the crop is 1,200 meters long and 800 meters wide. Show that the area of the land is 96 hectares. So 1,200 multiplied by 800, that's in, let's say, square meters divided by 10,000. So you get a 96,000 divided by 10000. So that is 96 hectares. So make sure you show the calculation explicitly. Okay, how you get the area by length times height and then divided by the conversion factor. The fertilizer being used on the land contains two active ingredients, A and B. The ratio of ingredients is 1 part ingredient A to 3 parts ingredient B. So a quarter will be A, 3/4 will be B, something along this line. It is known that a 25 kilograms bag ingredient costs $35. 25 bags of ingredient B cost $46. 200 kilograms of fertilizer will cover 1 hectare. So eventually you have, let's say, how many kilogram of fertilizer? I would say 200 multiplied by 96 equals to, let's say, 19200 kilograms, something along this line. That's in total. And all of the total amount, a quarter will need to be A. Therefore, 19200 multiplied by a quarter, or 25%. And that's the total weight of ingredient A. Then we divide it by, let's say, ingredient A in 25 kilograms per bag. Then we multiply by the cost, $35, plus 19200 multiplied by 3/4. That's the remainder of the total weight of fertilizer, divided by still 25 kilograms per bag for ingredient B. Then we multiply by the cost per bag, 46. So this calculation here calculates how many bags of ingredient A. This calculation here gives you how many bags of ingredient B in 25 kilograms per bag. And then we use the number of bags multiplied by the cost for each individual part. Then we can calculate, let's say, the total amount I need to pay for this much fertilizer. So that's the final answer. If you believe me, you can just type in the 2 chunk of calculations here and into the calculator, and then you get the final answer. Of course, another way you could calculate this is, totally, we don't talk about the total. We talk about, let's say, for each hectare, we can figure out how many bags. Let's say 200 kilograms, you have 50 kilograms of A. You have, let's say, 150 kilograms ingredient B. So that needs 2 bags. That needs, let's say, 6 bags, I would say. So 2 times, let's say, $35, that's $70. And 6 times 46. So that will give you $276. And sum them up. Each hectare needs to spend 70 plus 276, that will be $346. And then 96 hectares. 346 times 96, so that gives you $33,216. So that is another possible way you can calculate this problem. In fact, this is a very nice ratio problem, worded problem, application. The farmer sprays the fertilizer using a boom sprayer attached to a tractor. The boom sprayer covers land width of 20 meters. The tractor moves at a speed of 16 kilometers per hour. An extra 20 minutes of time is taken the tractor to make all its turns. Calculate the total time in minutes the farmer would need to take to spray the fertilizers on the land. So remember, look at the beginning. The dimension of this land is 1,200 meters long and 800 meters wide, something along this line. So if you go with a diagram like that, like this is 800 meters. This is 1,200 meters. So for example, the span, land width of 20. Suppose, let's say the tractor goes this way, okay? Goes this way. Then how many lots of 20 meters do we have? There are 40 lots, or let's say 40 rows, okay? For each row, let's say the tractor needs to move 1,200 meters. So we say 1,200 divided by 16 kilometers. Actually, should be 1,600 meters. So that actually gives you, let's say, a time here. Let me just do that calculation quickly. 1,200 divided by 1,600. Actually 16 kilometers. That should be an extra 0 here. Let me just do that properly. Yep. So you get, let's say, 0.075, or let's say 3 out of 40 hour, okay? And then because we have 40 rows, 3 over 40 times 40, that's 3 hours. And also you need to take the 20 minutes into account. Therefore, the total time will need to be, let's say, 3 hours and 20 minutes. The question says in minutes completely. Therefore, it will be 1,800 plus 20. That will be 200 minutes. Okay, going that way, that way, that way, that way. Sum them up, and all the time to make the turns, make the U-turns will be, let's say, 20 minutes. So we have taken everything into consideration. Yep, a very lovely real life example, but you have to understand what's really happening. Question 6. Two tenants renting a house in 2025 use some of their after-tax incomes to cover essential expenses. Assume that they are exactly 52 weeks or 26 fortnights a year, and we also assume there are 12 months. The essential expenses that need to be covered by the tenants are given in the table below: food, internet, rent, subscriptions, utilities. Show that the annual cost of the essential expenses for this tenant is this month. Okay, so if the food is calculated on a weekly basis, we have 250 multiplied by 52 plus internet 80 times 12 months plus 2500 times 12 plus 50 times 12 plus 650 times 12. So eventually, once you get this calculation, because the question has 2 marks for show that, you probably want to show, let's say, some grouping, like this number is 13000, and then you have a 12 multiplied by 80 plus 2500 plus 50 plus 650. So you get 13000. You can do the small calculations on scientific calculator. I'm so used to CAS calculator. 12 times, let's say, this number 3280. You can add them up separately, and then you get a 13000 plus 12 times, let's say, 39360. Oh, bear with me. You don't have the 12 here because you already done, let's say, the multiplication. So this number will be, let's say, 39360. So eventually it's 52360. So that's the annual cost of the essential expenditure. All right. The 2 tenants contribute equally to the cost of the essential expenses. One tenant earns an after-tax income of $5,000 per month. Maximum monthly saving this tenant can make after they have paid their share of essential expenses. Random answer to the nearest cent. So monthly saving this tenant can make. So we say 5,000 is your income minus the annual divided by 12. And two tenants contribute equally, so 50-50. Therefore, each tenant is taking half of the spending. If you calculate this one, you'll be able to get, let's say, 2818.33 cents, I suppose. Let's have a look. 5,000 income minus, let's say, 53260. Oh no, actually 52360 divided by 12, then multiply by half. Yep, 28183 recurring, so we round it to 33 cents. The other tenant earns an after-tax income of $28 per fortnight. The annual before-tax income can be determined using the rule annual after-tax income. So that is 2800. That's per fortnight, okay? Actually, fortnight, I mean, yeah, 26 equals to 9212 plus 0.7. Let's put this as x, 0.7x, okay? And then we can do 2800 multiplied by 26 minus 9212. You get 63588. Equals to 0.7x, and x is 63588 divided by 0.7. Let's calculate what's happening here. Divided by 0.7, 90840. So that's the second tenant's before tax income each year, annual, okay? So before you use this number, you have to use the $2,800 and convert it to the annual after-tax income. Make them the time duration consistent, something along this line. All right, question 7. 700 Australian children. Yep, the sample size 700 children, age 12, were surveyed about their mobile phone use in both 2020 and 2024. Graph below displays the survey result as percentages. State the most common mobile phone use in 2020. So we look at the gray ones. We look at the largest number, 64, 68, 64, 76, 74, 64, 71. So I would say it's here, okay? That's 76%. In 2020. Send or receive text. State the mobile phone use that show the largest increase in percentage between 2020 and 2024. Largest increase. So we want to see the largest gap here. It's this much, this much. We can actually write them down. That's 10%, that's 12%. That's 14%. That's 9% increase. That's a 3%. That's an 8%. That is a 6%. That is 12%, I suppose. That is actually. Oh, sorry. That's not a 12%. Bear with me. Nah, it's not the other way around. I believe that this is 18%. Okay. This is like if you 61 take away 49, that's 12%. 69, 49, 20%. So which increment is the largest? Which percentage increment? It's here, okay? So call friends. Okay. For the Australian children surveyed in 2024, calculate the difference between the number of children who indicated that they take photos or videos and those who access the internet. So 2024 use the take videos or photos. That's this number here. And access the internet 61. So we compare these two percentages with the stem-based number 700. So 700 multiplied by 80% minus 61%. And that'll be 700 minus 19%. Therefore, it will be, let's say, 133 children. Let me confirm this with you. 700 times 0.19. That's the decimal form for percentage, 133. Yep, correct. A survey with a broader age range was conducted for children aged 8 to 13 years old about their mobile phone use. The results are presented in the radar graph below. The following data is missing from the radar graph. 60% of 10 to 11 years. So 10 to 11 years old, 60%, it's along this line here. Core family, so it's this location here. And the radar graph, we need to join the edges. So I'll put a point here, use a straight line here, and also use a straight line segment here to complete this radar graph. Make sure you use the same legend or key, solid line, rather than, let's say, small dash line or larger dash lines, okay? Yeah, that's pretty easy, as long as you understand what's that about. All right, the playing area of a standard netball court is a rectangle 30.50 meters long and 15.25 meters wide. The playing area is divided into thirds with center circle that has a diameter of 900 millimeters. That'll be 90 centimeters or 0.9 meters, something along this line. There is a semicircle at each end of the playing area with the radius 4.9. So you have a semicircle here, and a full smaller circle here. The radius of the center circle in meters. So radius center circle is 0.9 meters divided by 2. So you get a 0.45 meters. Okay? And the next thing is calculate the area in square meters of the safety clearance zone shaded in the diagram. Okay, so it's the outer bit, okay, outer bit. So you can actually take, let's say, it's like, you don't have to break them into, let's say, small corners like that. You can just use the slab method. What kind of slab method are we using? See, this is one slab, this is one slab. So for example, you will get, let's say, 2 lots of 3050 plus 2 lots of 3.05. That's the total length multiplied by the width 3.05. So you count these 2 bits, and then you get, let's say, the smaller slabs, 2 lots of 15.25 multiplied by 3.05, something along this line. To save my bit time, I'll be using copy and paste for the calculation here. Let me just copy that. Copy that over there, cut. So this is one possible calculation. Remember, you have 2 slabs at the top and the bottom, and also the other 2 slabs at each end, left and right. If you chuck them into a calculator, you get a 316.285. The question wants you to round it to the nearest whole number in square meters. Therefore, it's 316 square meters. Okay, all the line markings on the playing area are painted. So playing area, I suppose you get, let's say, let me just use a highlighter here, 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 here. Do I need to mark the center circle? Including the two semicircles and the center circle. Yep. So why don't I just take a snippet of this diagram for your reference, and I can also see them clearly. So just let's say actually, let me do that again. Take a no. So for example, I would count 2 times 30.50 plus 4 lots of 15.25. Yep, that down, that down, that down, that down. And the 2 semicircles, I don't want to count these 2 diameters again. It's already included in the 4 times 15.25. So I just do 1 circle, 1 big circle, that is pi times 9.8, because the diameter is twice the radius, plus let's say pi times 0.9, pi d or 2 pi r, that's the length of the circumference. Okay, so eventually you will be able to get, let's say, 155.615, something along this line, and then you get 155.6, 1 decimal place in meters. So that's how long the painted line marking will be. Okay. Yep, looks pretty good. Question 9. The cost breakdown of a takeaway cup of coffee is shown in the infographic below. Using the information above, like each cup of coffee, the cost is $5.50. Show that the cost of the cup and lid is 26 cents. Cup and lid 4.8. So we have $5.50 times 0.048, something along this line. So if I show the calculation here, this will give me 5.5 times 0.048, so 0.264, which is rounded to, let's say, 0.26, and that's 26 cents. Yep. The volume of the takeaway cup is 236 mils. Assuming the direct variation between the cost and volume, calculate the volume of milk used in the cup of coffee. Rounded answer using a leading digit approximation. So if you look at the amount of milk, that's 11.9%. So 236 mils times 11.9%. So if you use your calculator, get 236 times 0.119, so 28.084. And leading digit approximation. Leading digit is this 2 here. Do I round it down to 20 or round it to, let's say, 30? Think about this. This is 20. This is 25. This is 30. Draw a number line and locate the rough position of 28. 28 is, let's say, over there. So is this point closer to 30 or is this point closer to 20? It's closer to 30. Therefore, we round it closer to 30 mils. Okay? So that's how I interpret the leading digit approximation. You can use a number line like what you did in year 7. The coffee is made by a barista who earns the wage of $26 per hour. If the barista works an 8-hour shift, calculate the minimum number of cups of coffee the barista would need to make to cover the cost of this wage. So 8 hour times 26, that gives you $208. So that's the amount of money the coffee shop needs to pay this guy. Now, we need to go back and check the wages cost. That would be, let's say, 34.6%. So each cup of coffee, that's $5.50, and then in each cup of coffee, the cost $5.50 times, let's say, 34.6%. So let's figure out how much money within each cup going to the barista. 0.346 multiplied by 550. Yeah, 1.903. And then, yep, the next thing is we use the total amount of wages divided by, this number here, 208 divided by that. Yeah, we get 109.3 cups. But you don't want to lose money. You have to make sure the number of cups sold to the customers can cover the cost, to fully cover the cost. Therefore, we need 110 cups. Otherwise, it's not enough to cover the cost, okay? So for this question, we need to round it up and using our day-to-day, daily life common sense. Yep, this one is okay. Then, question 10. The stacked area chart below shows the amount of principal and interest owing on a $400,000 loan over 9 years. 9 years. So that's 9 times 12. That's 108 monthly repayments. The interest rate on this loan is 0.5% per month. The interest is added at the end of each month. Repayments are 4,803 per month, round up to the nearest dollar. So after the first payment is made, the reduction in amount of principal, let's have a look. I would say 0.5% per month divided by 100 times your principal. So that will give you, let's say, 2,000. The next thing is 4,803 is the payment. Take away 2,000 interest. That'll be 2,803. So that's the reduction after the first payment is made. Okay. Yep, that's pretty much the reduction for the first month. The next thing is calculate the total number of repayments need to fully repay this loan. 9 years times 12 months. Each month you have one payment. So that's 108 repayment. So this question is another way to ask you how many months are there for this duration of this loan. The total amount that will be repaid for this loan is $518,724. Calculate the average amount of interest that will be repaid each year over the life of this loan. Round your answer to the nearest $10. Average amount of interest, so 518,704. That's the total payment. Take away the principal divided by, let's say, how many years? 9 years. So that will give you $13191.56, etc. And then you round it to the nearest $10. So the nearest $10 will be, let's say, 13190. I know it's sometimes confusing. Why do I round it down? Why do I round it up? It depends on the context. Like this one is just the normal decimal rounding, nearest $10. You can also, let's say, okay, this is, just look at the 91, 90, and 95, for example. Actually, bear with me, it's not 95. $10 increment, this is 95. 91 is over there, very much close to 90. Therefore, using the normal rounding, we round it to 90, round it down, okay? Anyway, we can move on and have a look at, let's say, question 11. The graph below shows the average household electricity prices in selected countries from the Organization of Economic Cooperation and Development in 2024. Electricity prices are given in United States dollars, US dollars, per kilowatts hour. The household electricity prices, yeah. Okay, find the simplest ratio for the average household electricity price in New Zealand compared with the average household electricity in Chile. Okay, so New Zealand is 0.205 divided by Chile. The price is 0.164. If you have a scientific calculator, I believe most of the scientific calculator is able to do the division like, say, 0.205 divided by 0.164. So it gives you 5 to 4. Okay, 5 to 4. We could say New Zealand to, let's say, Chile. That is 5 to 4. Okay. A dishwasher in Australia uses 1.8 kilowatt hour of electricity each hour, 35 hours. So 1.8 times 35 hours times, the electricity price for Australia, that is 0.912. 0.192. Bear with me. $120.96. But remember, this is US dollars. So I'm going to use a ratio method. For example, 1 Australian dollar equals to 0.94 US dollars. So if I divide both sides by 0.64, that'll be 1 divided by 0.64 AUD equals to 1 US dollar. Therefore, when you multiply these two by 120.96, so I would get 120.96 multiplied by 1 over 0.64. Basically, it's divided by 0.64. So you get 189. That is 35 hours each month. Yeah. Hold on a second. Calculate the cost in Australian dollars of running the dishwasher for one year. Oh, cheeky. Yeah, this is each month. Okay, so I need to go 189 multiplied by 12. Bear with me. Is that correct? Hold on a second. Let me double check. Oh, Jesus. This is 1.8. How could I miss this thing here? Oh, I need to multiply this by 12. Yep, let's have a look. Yeah. Divided by that. I need to divide it by 0.64. 2 to 6 point, something along this line. Let me have a look. Nah, this bit should be 12.0.96. Let me just write this number. Should be that. Let me do the calculation again. Sometimes I'm not so confident with the basic arithmetic. I have to double check. I always second guess myself. 0.2 192. That's the electricity price. 1.8 kilowatts hour times 35 hours per month times 12. Yep, that's the total amount of money, and that'll be in US dollars, then divided by 0.64. Yep, 226.8, something along this line. 226.8, and it's rounded to, let's say, $2 to $7. Yep. Okay, now part C. A website rates dishwashers based on selected criteria, with each criterion given an importance, weighting based on their feedback. The following results were recorded from a sample of 50 users for a selected dishwasher. In this table, AR is defined as an average rating out of 10. A weighted score is the weighted score equal to sum of weighting times AR. So we need to calculate the weighted average. All right. I probably would say, okay, 0.4 times 8.5, 0.2 times 80. So that'll give you, let's say, 1.6. That'll give you, let's say, 3.4. That'll give you 1.2. That'll give you 0.75, and that'll give you 0.90. So we can add them up. Weighted average. Basically, it's like the problem stat content you did in year 9. Like you do a sum, like a sigma, something along this line. So you do 3.4 plus 1.6 plus 1.2 plus 0.75 plus 0.9. So that'll give you 7.85. Yep. 3.4 plus 1.6 plus 1.2 plus 0.75 plus 0.90. 7.85 rounded to 7.9. Correct to one decimal place. Just notice you can't really add up, let's say, you can't add up the AR score divided by 5 because these 5 data values, they have different weighting. You have to use weighted average method, like the frequency multiplied by the score and then divided by the total frequency, etc., etc., okay? So basically, you could argue that, yeah, the frequency table, and then calculate the weighted average. Question 12. Okay, hopefully that's the last question. Sandbags are used to deflect the flow of water from a burst water main. The sandbags are stacked to form a wall with bags overlapping. Each sandbag is filled with dry sand to only 2/3 full so that it can be carried. A rule that combines density, weight, and volume is given by density equals to weight divided by volume. Dry sand has a density of 1,600 kilograms per cubic meter. The conversion from cubic meters to liters is 1 cubic meter equals to 1,000. Use the rule above. Calculate the volume in liters of 20 kilograms of dry sand. Okay, so what I'll do is the density. The density is like here. The weight is 20. The volume is unknown. Therefore, V equals to 20 divided by 1,600. So that'll be 1 out of 80 cubic meters. Okay. So far, I'm using, let's say, kilogram per cubic meter. That's kilogram. That's cubic meter. The next thing is I'm going to convert the volume in cubic meters into liters. So 1 out of 80 times, let's say, 1,000, which will give you 12.5 liters, I suppose, if I'm not mistaken. So it's actually a small algebra problem. A sandbag that is 2/3 full contains 20 kilograms of dry sand. Calculate the volume in liters of dry sand in a sandbag that is completely full. So I would say 2/3 full, that's 20 kilograms. 1 full, that is 30 kilograms. Okay, so we have 1600 equals to 30 divided by V. Use the density formula, then V equals to 30 divided by 1600. So that gives you 3 out of 160 cubic meters. And then we multiply this by 1,000. 3 out of 160 multiplied by 1,000, which will give you 18.75 liters. The question wants the answer in liters. This one, I saw this question. It's indeed a challenging question, and you have to think carefully. The length of the filled sandbag is 900 millimeters. The height of the filled sandbag when stacked is 250 millimeters. So it's 0.9 meters. You have, let's say, 0.3 overlap in meters. 250 millimeters, that's a 0.25 meter, I suppose. A wall is 18.3 meters long and 1.5 meters high. It's being built in front of a property. Calculate the number of filled sandbags that will be needed to build this wall. Well, if you think of the the first bag like this one, this will be you have some flat end. Therefore, you can stack the next one here. So actually, it's not using the full bag, something along this line. Therefore, the first bit is 0.9. The next bit, you can say this is just 0.6 meters extra, okay? The next one will also be, let's say, 0.6 extra. So the total horizontal dimension, 18.3, take away 0.9, will give you 17.4 meters long. And I'm going to use, let's say, 17.4 divided by 0.6. Basically, we just add, let's say, like 0.6 each time, 0.6 each time, okay? So that'll give you, let's say, 29 extra bags. Because I already have one bag at the start of the stacking, then I just need to slot in 29 extra bags. So all the 30 bags are fully stacked. So horizontally, we need 30 bags. Then vertically, we can't really, let's say, do the stacking. We have to do, let's say, layer by layer. So in order to fully occupy 1.5 meters high, then we say vertically 1.5 divided by 0.25. That'll give you, let's say, 6 bags. Horizontally, you have 30 bags. Vertically, you have 6. Therefore, 30 times 6 equals to 180 bags. So that's how I would answer the question using some, graph drawing and also calculations. Yeah, end of examination questions. Hopefully, my explanations could help you a bit if you are doing foundation math course and are looking at this, watching my video. That's it. Thank you very much for watching. I will see you in the near future, and a Merry Christmas.